Critical thinking rule 9, background rates are often crucial. There are two types of background rates. The textbook A Workbook for Arguments by Morrow and Weston doesn't do a great job of distinguishing between these two, so I'll add a little bit of information here. The first type of background rate is just related to the idea of doing a good job of creating a representative sample for your generalization. So this is a general overall relation between two variables. Example, the number of successful astrologer predictions versus the total number of astrologer predictions. If someone says, my astrologer said I would get the job, and she was right, and this is being used as evidence for the generalization, my astrologer makes correct predictions. In order to assess this generalization, not only would we like some more examples, but also we need to get a sense of the total number of predictions and how many were successful versus ones that were unsuccessful. So people have a tendency to remember examples of a generalization that they favor and to ignore or downplay examples that conflict with that generalization. So that's the background rate that's missing here, just the overall rate of success of the astrologer's predictions. A second type of background rate is the baseline ratio between two variables that's used as a basis for comparison with a subsequent or later ratio. So this is when you're looking at a population at two different times, for example, and you're making not only a generalization about the properties of the population at one time, but how it compares to the properties of the population at another time. It's also possible to compare a population with another similar population. So you can index the comparison to different types of values. Let me give you an example. The crime rate in Louisiana. If someone says in 2018, the state of Louisiana had 11.4 homicides per 100,000 residents, crime is out of control and getting worse. Notice they're not only making a generalization about 2018, they're making two further claims. Crime is out of control. So this implies the homicide rate is very bad. And they're saying it's getting worse. So in order to assess the claim, crime is out of control, it would be good to compare the current homicide rate or the homicide rate in 2018 with the homicide rate of other decades, such as 30 years ago, or the homicide rate of other states in the United States or other nations. And if you're saying particularly the crime rate is getting worse, then you absolutely need to compare the crime rate of 2018 with that of previous years. So those are the background rates that are missing from this claim. So background rates also show up in scientific experimentation. Scientists distinguish between independent variables and dependent variables. The independent variable is the one that's hypothesized to explain variation in a dependent variable. So the independent variable is the one that you can vary experimentally. You shift it from trial to trial to see if that shift has any effect on what you're observing in the dependent variable. You can say that the background rate in a scientific experiment is the rate at which the dependent variable would be present in the population, regardless of whether the independent variable is present. Let's look at a particular example. Suppose you're trying to assess this claim. College graduates have better critical thinking skills than before they started college. Therefore, college improves critical thinking skills. This is actually a type of argument, a causal argument that we'll discuss in a later chapter. But it starts with the claim that college graduates have better critical thinking skills than before they started college. So what's going on here is you're saying that going to college is the independent variable. The dependent variable is their critical thinking skills. You can see this very clearly in the causal claim. College improves, i.e. causes an increase in critical thinking skills. Now, in order to assess this claim, we would have to determine a background rate. So for instance, how much would these people's critical thinking skills get better over time, even if they did not go to college? So that's what's totally missing from this argument. It's possible, for example, that human adult brains are still developing in late teens, early 20s, which are usual college years. And so those critical thinking skills might develop even for people who don't go to college. So in scientific experiments, they typically have a control group and an experimental group. The experimental group is a sample exposed to the experimental intervention. In the college example, it would be going to college. The control group is the sample not exposed to the experimental intervention. This would be a sample of people who did not go to college during the same years. The control group results are the background rate for the experiment. So it's crucial to have a control group in scientific experiments to figure out what would happen even if you did not introduce the independent variable that you're trying to assess. So another example is if you wanted to look at bullet journaling, which has been kind of a fad, I guess, the last few years, to see if it helps people improve their studying. So in order to do this, you wouldn't just give people this technique, say, use the bullet journal technique and then test them on a subject. You would want to compare the sample of students given the bullet journaling technique with those instructed to use another technique, such as just reviewing their notes or spending some time reading the textbook or whatever. That control group would give you a background rate to assess exactly what effect the bullet journal is having on their outcomes. Cognitive biases and heuristics are relevant to a lot of areas of critical thinking, including ignoring background rates. A cognitive bias is a systematic deviation from rationality in thinking. Rationality here means using all the reasons and evidence that are available to assess a claim. If there's a bias in ignoring certain reasons or putting more emphasis on others, then that would be a cognitive bias in rationality. A heuristic is a cognitive shortcut that may be efficient, such as in time or resources, but which may fail to be rational. So it can leave out reasons or evidence that are relevant to assessing the truth of a claim. The infographic on the right is a very clever list of all the known or named cognitive biases. Cognitive bias and heuristic research originated in cognitive psychology, I believe in the 1970s, especially through work of Daniel Kahneman and Amos Tversky. So here's an example of a cognitive bias. Confirmation bias is a tendency to remember and emphasize events that confirm a generalization and to forget or downplay events that conflict with the generalization. A particular example of this bias could be looking for examples to support a generalization that your coworker is a bully. So this often happens with human interpersonal relationships. If we form an initial impression of someone, whether good or bad, that can bias our subsequent judgment of that person's behavior. And that can appear in the form of a confirmation bias. Oh, if we think that someone is a bully, or someone is lazy, or someone is responsible, then if they perform actions in the future that conflict with that, we may just downplay or ignore those, and then we'll highlight examples of their actions that support the generalization we've already decided on. An example of a heuristic is the availability heuristic. This is when the mind relies on examples that are easy to recall, remember, or are salient or noticeable, but which may not be representative of the group of things that we're generalizing about. So a particular example of this is the idea that if you become an actor, you'll be rich and famous. A lot of people seem to believe that, but this is a clear example of availability heuristic. The vast majority of people who become actors do not become rich and famous, and only a tiny percentage of members of the Screen Actors Guild, for example, which itself is just a subset of all actors, only a tiny percentage of those people actually can support themselves full-time through acting. The reason why we have this delusion is because the actors that we're familiar with tend to be those who are famous, and often those famous people are also rich from their acting, or relatively speaking. And so, by definition, fame is going to make people more well known to the general population. So we're more familiar with the famous actors, even though the vast majority of actors are not famous. Next up, Rule 10. Statistics need a critical eye. This is kind of a miscellaneous or grab bag rule, various techniques to help you avoid errors in reasoning about generalizations.